Okay, so period 2, I forgot to mention to you in the notes from today, the bottom part of our notes on how we do those problems, and you need that to do the homework for today. So I want to describe that here. It should take really no more than 5 or 10 minutes. Okay, so let's go ahead and get started. Basically, you need to know the process in terms of how to find the limit of a certain function or sequence. The way we do this is, oh, that's really thick. Let's write it again. The process involved, and you should write this in your notes as well, is that first step, you need to divide each term by the highest power of n in the denominator. The second step is then to simplify. The third step is then to evaluate as n goes to infinity. And one thing that we need to remember is that we want to write the limit as n approaches infinity at every step, at each step. So let's go ahead and do some practice problems here. We'll start off with number 5, the limit as n approaches infinity of 2n minus 6 over n plus 10. This is in your notes, so make sure you find that problem and do that in your notes. So in our steps here, what we need to do is divide each term by the highest power of n in the denominator, which in this case is just n to the first power. So we rewrite it. Make sure you write the limit as n approaches infinity every single time. And we divide everything by this n. So 2n over n minus 6 over n. Over, then we have n over n plus 10 over n. So we just simplify it all out now. Now that we've divided everything by n, when we simplify it, we get the limit as n approaches infinity of, now when we simplify, these n's will cancel out. We're left with 2 minus 6 over n over n simplifies to 1 plus 10 over n. And it's at this step now that we can actually apply our limit. So as n goes to infinity, think, 2 is not affected by n at all. 6 over n though, that's like 6 over infinity as n approaches infinity. 6 over infinity is basically going to 0. 10 over n is basically going to 0, and there's no n in this 1, so it just stays the same. So simplifying this out, we get 2 minus 0 over 1 plus 0, and we don't need limit anymore because now we are evaluating it. So 2 minus 0 gives us 2, and 1 plus 0 gives us 1. So basically we're seeing that this converges to 2. Like that. Okay. Let's try the next one. Number 6. The limit as n approaches infinity of 29n plus 10 to the 5th over 5n squared minus 8. So first thing we do, divide everything by the highest power of n in your denominator, which in this case is n squared. So limit as n approaches infinity of 29n divided by n squared plus 10 to the 5th divided by n squared over 5n squared divided by n squared minus 8 divided by n squared. Let's simplify. We get the limit as n approaches infinity of, these n's cancel out, we're left with 29 over n plus 10 to the 5th over n squared over, n squareds will cancel out here, and we're left with 5 minus 8 over n squared. And now we can do our magic of limits. Anytime we see n on the bottom, 29 over n, that will go to 29 over infinity. That goes to 0. 10 to the 5th over n squared, that's like saying 10,000 over infinity. Well, 10,000 is so insignificant compared to infinity that this also just goes to 0. 8 over n squared, we see that goes to 0. Oops, that goes to 0 here. So all we have left is basically 0 plus 0 over 5 minus 0, and that gives us 0 over 5. So this converges, can't spell, converges to 0, like that. Okay? And that's it. So now you should be able to do your homework for today. And that's it.